Good day everyone. Today we are going to tackle about the binary search algorithm. So what is a binary search algorithm? A binary search algorithm is defined as a searching algorithm. It is an efficient algorithm used to find the target value in a sorted array. The idea of a binary search is to use the information that the array is sorted and reduce time complexity to zero. It works by repeatedly dividing the search interval until the target value is found or the search interval is empty. So how does the binary algorithm works? A binary algorithm is a binary search is an efficient algorithm for finding an item from a sorted list of items. It works by repeatedly dividing in half the portion of the list that could contain the item until you narrow down the possible location to just one.
So let's talk about a series of operations executed on a binary search algorithm. Suppose we are given a sorted array of integers, which is 1, 3, 5, 7, 9, 11, 13, and 15. Our target value to find is 9. So let us know how to get our target value. To make this topic understandable, let's solve this until the target value will be found. So here, we start by setting the low variable to 0 and the high variable to the length of the array, which is 7. So in this case, low is 0 and high is 7. We calculate the mid variable by adding low and high and dividing by 2. In this case, mid is 0 plus 7 divided by 2 is equal to 3. We compare the value of the mid index, which is 7, because our mid is 3, with a target value of 9. Since 7 is less than 9, we know that the target value must be in the second half of the array. We update the low variable to mid plus 1, which is 4. So our mid 3 will become a 4. So we calculate the new mid variable by adding low and high and dividing by 2. In this case, mid is 4 plus 7 divide 2 is equal to 5. We compare the value of the mid index, which is 11, the target value of 9. Since 11 is greater than 9, we know that the target value must be in the first half of the array. So we update the high variable to mid minus 1, which the mid 5 will become a 4. We calculate the new mid variable by adding low and high and dividing by 2. In this case, mid is equal to 0 plus 4 divided by 2 is equal to 2. We compare the value of the mid index, which is 5, because our mid now is 2, with a target value of 9. Since 5 is less than 9, we know that the target value must be in the second half of the array. We update the low variable to mid plus 1, which is 3. We calculate the new mid variable by adding low and high and dividing by 2. So in this case, mid is 3 plus 4 divided by 2 is equal to 3. We compare the value of the mid index, which is 7, with a target value of 9. Since 7 is less than 9, we know that the target value must be in the second half of the array. So we update the low variable to mid plus 1, which is 4. So we calculate the new mid variable by adding low and high and dividing by 2. So in this case, 4 is our new mid plus 4 divided by 2 is equal to 4. So we compare the value at the mid-index, which is 9, with a target value of 9. Since the values are equal, we have found the target value. Therefore, the binary search algorithm has successfully located the target value, which is 9 in the array. That's it.
Okay, so let's create a binary search algorithm in NetBeans. So basically, open NetBeans, and then I'm pretty sure you already know how to create Java class. So let's name binary search algorithm to our class. So inside the binary search class, we create a binary search method. This method takes two parameters, an array of integers, r, and an integer target that we want to search for in the array. We initialize two variables, left and right, to represent the indices of the left and the right boundaries of the search interval. Initially, left is set to 0, which is the beginning of the array, and the right is set to r.length minus 1, which is the end of the array. We enter a while loop that continues as long as left is less than or equal to right. This loop will keep dividing the search interval until we either find the target or determine that it's not in the array. Inside the loop, we calculate the middle index mid of the current search interval. Using the formula mid equals left plus open parenthesis right minus left in close parenthesis divided by 2. This ensures that we always take the middle element even in cases where left and the right are large. We compare the element at index mid in the array with the target. There are three possible scenarios. If r open bracket mid and close bracket is equal to target, we have found the target, so we return mid. If r open and close bracket mid is less than target, the target must be in the right half of the current search interval, so we update left to mid plus 1. If r open and close bracket is mid is greater than the target must be in the half of the current search interval, so we update right to mid minus 1. If the while loop exits without finding the target, like for example left becomes greater than right, we return minus 1 to indicate that the target is not in the array. Negative 1 rather. In the main method, we create a sorted array called sorted array and a target value called target. We call the binary search method with sorted array and target as arguments and store the result in the result variable. Finally, we check the value of result. If it's not equal to negative 1, we print a message indicating that the target was found along with its index in the array. If it's negative 1, we print a message indicating that the target was not found in the array. So if we run the code, So the output must be target 6 found at index 5. It is target 6 because we initialize it in the target 6, and then at index 5 because it is in the index 5. So that's how we implement our code in binary search algorithm. That's it. Thank you.
And this is the end of our discussion. I am Aldrin Jay L.
And I am Gerald S.
Don't forget to like
and subscribe to our YouTube channel. Thank you.